So now our topic is Raoult's law. So in Raoult's law, what we study that the partial pressure, basically partial vapor pressure of a component is directly proportional to the mole fraction of that component. In liquid phase. So what you are saying, first of all, we have to remember that this law is for liquid solution, and both are liquid volatile solution. So what we are saying that if I have a system which have two components, assuming A component and B component, so it will form vapor because both the components are volatile. So if it forms vapor, then we will have some vapor pressure. So in above region which I am shading, we will see vapor pressure. What we will see? We will see some vapor pressure. So we are calling it as partial vapor pressure. This is partial. Why we are calling partial? Because in this vapor phase, we have two components. So both components will contribute to some pressure. That's why we are calling it as partial vapor pressure. So this partial vapor pressure, by Raoult law, it will be, if I am talking about PA, it is proportional to mole fraction of A, and this mole fraction is of liquid phase. In solution, we can say that it is in solution. So by solving further, we can write it as we know that the proportional sign is changed to proportionality constant. Then we see that this proportionality constant is equal to PA naught, which is defined as pure partial pressure. Here, if we are talking about pure component, so we can neglect this term partial. We read it as pure vapor pressure because it is not partial, pure vapor pressure. I'm explaining again. This PA naught is calculated by putting that gas component in a system which have only that component. So we will not have partial pressure. That's why we are calling it pure vapor pressure. So PA naught is equal to that pressure. What is PA naught? It is that pressure which is measured when we have only that component in a particular chamber in a particular system. So that's why we call it as pure vapor pressure. So I can define it as pressure when we have only a component in system. So moving further, if I draw its graph, it is linear graph. You may have studied earlier that it is kind of y equal to 3x, y equal to 4x type of graph. So it is linear graph. So it will be like this. Here In x-axis we will have mole fraction, which will increase from 0 to 1, and on the y-axis we will have vapor pressure, partial vapor pressure. So it will be linear graph. Now moving for B component, if I talk about B component, so by Raoult's law we can say that PB is what? PB is the partial vapor pressure, partial vapor pressure by component B over the solution. So this pressure will be directly proportional to mole fraction of B in solution. So we can write it again like PB is proportional to XB. So by putting proportionality constant, we will get PB naught multiply XB. So now you can easily understand that PB naught is in that condition when we have only B component in a particular system. So the pressure created on the wall of the system will be equal to, so I am writing here, pressure by only B component is PB naught. So we can also draw its graph. It will be linear like earlier. It will be linear. On x-axis I am putting mole fraction of B. It will increase from 0 to 1 value. Maximum value will be 1. And on y-axis we will have pressure, wave pressure, and it will reach its maximum value at what value? PB naught. I can write it like, if xb equal to 1, PB will be equal to PB naught into 1, and it will become equal to PB naught. So I have marked here on the graph. This value will be gained when mole fraction will be 1. Similarly, for that graph also, we will have maximum value at mole fraction 1, and this maximum value will be equal to PA naught. So this is our Raoult's law for binary solution by taking only two components A and B. And moving further, we can also write total pressure on of vapor phase or vapor will be equal to PT, and it will be sum of PA plus PB because we have only two components. So it is easy to understand that only two components will contribute. So we are writing as the sum of partial wave pressure of both the component, and it is by Dalton's law of partial pressure. So PT will be equal to PA naught XA plus PB naught XB. So this is our total partial vapor pressure, or we can say that total vapor pressure created. It will be the total vapor pressure created if I have A component and B component. The pressure which will be created on this region which I am labeling here, it will be equal to PT, and it is equal to PA naught XA plus PB naught XB. So that is it for today. Thank you so much, and we will continue it further on next video.